Good afternoon, students. In continuation with properties of Z transform, we will discuss remaining properties of Z transform. Time shifting property of Z transform. If Z transform of x of n is x of z, then determine the Z transform of x of n minus k. And according to the definition of Z transform of x of n minus k is written like this: summation in from minus infinity to infinity x of n minus k z raised to the power minus n. And in this expression, we can write z minus n like this. So we replace z raised to the power minus n is by this, and in this, since limit of summation is from minus n to from n is equal to minus infinity to plus infinity, so we can take x of z raised to the power minus k outside the summation sign, and if we put n minus k is equal to m, then we get z raised to the power minus k summation x of m z raised to the power minus m. And this is also the x of z or z transform of x of m. So we can write z raised to the power minus k x of z. So z transform of x of n is given by this expression. It is equal to the z raised to the power minus k multiplied by x of z. So we can say that if sequence is shifted in time domain or for delayed time domain signal sequence, we simply multiply x of z by z raised to the power minus k. Or we can say that shifting the sequence in time domain by k samples correspond to the multiplication by z raised to the power minus k in the frequency domain. Find the z transform of x of n. X of n is given by delta n minus k, and we know that z transform of delta n is 1, and ROC is entire z plane. According to the time shifting property, we know that x of n, z transform of x of n is given by z raised to the power minus k multiplied by x of z. So z transform of impulse function n minus k is given by z raised to the power minus k multiplied by 1, because z transform of impulse function delta of n is 1. So here value of x of z is 1, and for this delayed sample we get x z of z raised to the power minus k. So ROC is entire z plane except z is equal to 0. Then find out the z transform of x of n is equal to delta n plus 2. Using time shifting property, we know that z transform of x of n plus k is given by z raised to the power k multiplied by x of z. Delta n plus 2 is given by this because z raised to the power k, where value of k is 2 and z of x is 1. So we get the z transform of delta n plus 2. And in this case, ROC is entire z plane except z is equal to infinite, because if we substitute z is equal to infinite, we get the z transform of delta n plus 2 is infinite. So entire ROC is entire z plane except z is equal to infinite. Next question is, if x of x1 of n is given by this sequence, then using the time shifting property, find the z transform of x to n, where x to n is given by this sequence. So x to n is written as x1 n plus 2, and we know that z transform of x of n plus k is given by z raised to the power k multiplied by x of z. And in this case, value of k is 2, so we get the z transform of x n plus 2 is equal to z raised to power 2 multiplied by x of z. First we calculate the value of x1z. Here we want to calculate x1z, and if x1n is given by this, x1z is given by this, and in this n, where n is 0, 1, 2, 3, 4 and 5. So value of n is from 0 to 5. This limit changes from minus infinity to plus infinity, and in this equation limit is from 0 to 5 x1n multiplied by z raised to power minus n. And then calculate the value of z transform of x to n is given by z to z is z square multiplied by x1z. x1z, value of x1z is 1 plus 2 z raised to power minus 1 plus 3 z raised to power minus 2 plus z 4 z raised to power minus 3 and z raised to the power minus 5. So we get the value of x2z, and then calculate the ROC simply by putting the value of z is equal to 0 and z is equal to infinite, and you get the ROC is entire z plane except z is equal to 0. When you put z is equal to 0, you get the value of z2 x2z is infinite, and when you put z is equal to infinite, you also get the value of x to z is infinite. So ROC is entire z plane except z is equal to 0 and z is equal to infinite. Next question, determine the z transform of following finite duration sequence. If x of n is 1 for this range and x of n is 0 otherwise, then find out the z transform of x of n. Suppose that un is given by this sequence and here un minus capital N means this is shifted by n capital N samples. And if you subtract this sequence from this sequence, you get a finite duration of unit impulse function. If this sequence is subtracted from this sequence, you get a finite duration discrete type pulse. And x of n is given by un minus capital N. Then according to linearity property, x of z or x of z transform of x of n is written as z transform of un minus z transform of un minus capital N. And we know that z transform of un is z by z minus 1 and ROC is absolute value of mod of z is greater than 1. Similarly, using shifting property, we can write z raised to the power minus n multiplied by z transform of un. And z transform of un is given by z divided by z minus 1 and ROC is exterior part of circle having radius 1. So putting the value of equation 3 and 4 in equation 2, we get value of x of z is this, and we get the z transform of un minus capital N by this expression. And for ROC, if combined of several signal has finite duration, then ROC is dictated by or determined by finite duration of signal. Means first un signal is of infinite duration. Second, the delayed signal is also infinite duration. But when we subtract second signal means delayed signal, when this signal is of infinite duration, this delayed signal is of infinite duration, but when we subtract this signal from this signal, we get a finite duration signal. And ROC, in this case, when we get finite duration sequence, in this case, ROC is determined by the finite duration unit step, not by individual ROC of infinite duration signals. So this finite duration unit step signal is causal signal. So ROC is entire Z plane except Z is equal to 0. Then next property is scaling in. Z transform. If Z transform of x of n is given by x of z, then find out the Z transform of a raised to the power n x of n. ROC is in this case is in between R2 and R1. According to the definition of Z transform, x of z is given by this. And if we put value of x of n in second case, x of n, value of x of n in this case, a raised to the power n x of n, z raised to the power minus n. And this equation can be written like this, and we can write this equation as x of n a raised to the power minus n multiplied by z whole square minus n. So this equation can be written as x of n z divided by a whole square minus n. So we get the z transform of a raised to the power n multiplied by x of n is given by this. And ROC is determined by, since ROC of x of z is in between R2 and R1, R1 and R2 are radius of two circles. So to obtain the ROC of x of z by a, z is replaced by z minus z by a. Here z is replaced by z by a. So z by a is in between R2 and R1. So absolute value of or mod of z is in between mod of a multiplied by R2 and mod of a multiplied by R1. So ROC of x of z by a is determined by this expression. Or we can say that scaling in time domain corresponds to the shrinking or expanding the z plane. This ROC is, and by taking a as a complex value, we can change the scale of radius and omega in the z plane. Obtain z transform of x of n is equal to a raised to the power n un by using scaling property. We know that z transform of un is given by z divided by z minus 1. ROC is mod of z is greater than 1. And according to the linear property, z transform of a raised to the power n x of n, not linear property, scaling property. According to the scaling property, z transform of a raised to the power n x of n is obtained simply by replacing z by z by a. And if we replace these z and this z by a, we get the equation z divided by z minus a, and ROC in ROC this z is replaced by z by a. So ROC is mod of z is greater than mod of a. Find out the z transform of x of n, where x of n is given by this expression. X of n is given by this expression. We can write this expression like this, and x of n is written as minus half raised to the power n un. In this case, value of a x of n is in form of a raised to the power n un, and you can say that a is equal to minus half. So first take the z transform of un. Z transform of un is equal to z divided by z minus a, and ROC is this. And by using scaling property, this z is replaced by z by a, and here this z is replaced by z by a, and so z transform of minus half raised to power n un is given by z divided by half divided by z divided by half minus 1, and here z is replaced by no z a. This z is replaced by z by minus half. Z by minus half. Z by minus half. Value of a is here minus half. So ROC is z. Mod of z is greater than mod of half, or ROC is mod of z is greater than half, or mod of z is greater than half. And if we solve this equation, we get this equation. So ROC is exterior part of circle having radius r is equal to time reversal property. If z transform of x of n is x of z, and ROC is given by this expression, or ROC is between R2 and R1, then find out the z transform of x of minus n. Z transform of x of n is given by this, so z transform of x of minus n is given by x of minus n multiplied by z raised to the power minus n. Putting L is equal to minus n, we get summation from plus infinity to minus infinity x of L z raised to the power n. If minus n is replaced by L, so the limit is changed from plus infinity to minus infinity x of L z raised to the power L, and we can write this expression like this. So we can say that z transform of x of n is given by x of z raised to the power minus 1, or we can say that x of n is folded version of x of n. X of minus n is folded version of x of n, or we can say that x of minus n is mirror image of x of n. So folding of signal in time domain is equivalent by replacing z by z inverse z raised to power minus 1. Z raised to power plus 1 is replaced by z raised to the power minus 1 in the z domain. Means if we replace n by minus n, then z is replaced by z raised to the power minus 1, and this is known as inversion. Hence folding in time domain is equal to the inversion in z domain. And in this case, ROC of x of n is between R2 and R1, So then ROC of x of minus n, this z is replaced by z raised to the power minus 1, which is written as 1 by z. So z is ROC is given by this expression. Obtain the z transform of signal x of n, where x of n is equal to u of minus n. Z transform of unit step function is given by z divided by z minus 1, and ROC is greater than or exterior part of circle having radius 1. And according to the time reversal property, z transform of x of minus n is given by x of z, x z raised to the power minus 1. Means z is replaced by, if we replace this z and this z by z raised to the minus 1, we get the value of z transform of x of minus n. So we replace this, and here we replace z by z in z raised to the minus 1. We get the value of z transform of u of minus n, which is equal to 1 by 1 minus z. And here ROC is given by this. So 1 by z is greater than 1. It means absolute value of z is less than 1. In this case, ROC is anterior part of circle having radius 1. This is the ROC. Means in this region, we get the z transform of x of minus n. Then determine the z transform of this z transform and ROC of x of n, and x of n is given by half raised to the power n u minus n. Using time scaling property, we know that z transform of u minus n is given by 1 by 1 minus z, and ROC is anterior part of circle having radius 1. So this is of a raised to the power n u minus n. It means if we use scaling property, according to the scaling property, where value of a is half, so we replace this z by z divided by half, and here we replace z by z divided by half, and we get the value of z transform of this expression. So ROC is anterior part of circle having radius half, and z transform of half raised to the power n u minus n is given by 1 by 1 minus 2z. Differentiation in z domain. If z transform of x of n is x of z, if z transform of x of n is given by x of z, then if we multiply n to this function x of n, then we get the differentiation of x of z. X of z is given by this expression, and if we differentiate both sides, we get dx of z by dx, and here if we differentiate this term, we get minus n multiplied by x of n z raised to the power minus n minus 1. And if we take this from the summation side, out of this summation side sign, then we get the z transform of n. X of n is given by, this is the z transform of n x of n. So we can write this expression like this, and we can say that this is the z transform of n x and n x of n. So we can say that z transform of n x and n is given by minus z dx of z divided by dz. Now time is over. Thank you.